Desk of LADYADA.
Hey everybody, welcome to another Sunday night Desk of LADYADA. We're on a roll. I think we've done about a month so far of Sunday night streams where we go over some DigiKey search and what we're up to here at the Desk of LADYADA. This is where all ideas are formed and then cast into the world.
That's right.
Turned into products.
Yeah, we are open, safe, and smart. The last time we were doing Desk of LADYADAs was back in
March, April.
And we had to stop because COVID stuff. Actually, it was peak death day, and that's grim. However, there is some hope. Today in New York, 8/9/2020, lowest positivity rate since they've been testing.
That's right.
So that means New York, we're under 1%, 0.78, 0.73. Today we spent the day doing things like swabbing Adafruit to see how many surfaces might have some dead virus load.
Yeah.
LadyAda and I got COVID tests because we have to set a good example and make sure we're getting tested frequently.
Up the nose.
So all of this stuff is just, part of now
This is a new normal.
doing business.
As they say.
And keeping everybody safe. So
Yeah.
when you place an order at Adafruit, it does help us a lot. So please do that right away.
We now have expenses for surface tests.
Exactly.
That's a new thing.
So we're going to keep doing this every single day. And we thank all of you who've been keeping us going all this time. LadyAda, what are we working on this week?
Okay, so I'm actually bringing to life a really old product. I was going to kind of finish this in March, and then March kind of took over. But late last year, we came out with a preview of the BrainCraft HAT, which was when I was doing a lot of machine learning projects. We did a bunch of TensorFlow guides for Raspberry Pi and for desktop, and programmable machine, the project from Google. Yep. And we were also doing TensorFlow Lite for microcontrollers. So we were doing a lot of machine learning. I was kind of like diving into the nitty gritty of it. So we designed a hardware helper for the Raspberry Pi 4, which had just come out. And the cool thing about the Pi 4 is that it has, even though it doesn't have hardware machine learning support, it doesn't have a core that's optimized for this CUDA add-on for TensorFlow, it is fast enough to just perform basic, just number crunching, object recognition type projects, which I think is what people really like. They want to be able to say is this my cat? Or is this a cat? Or is this an oscilloscope? Or is this, a person? Or how many people in the frame? And with the Pi 2 and Pi 3, they were getting better and better, but they weren't quite fast enough to get multiple frames per second, which I think you kind of need to have a good experience. So now you can do it, and it's really fun. So I'm getting back into that, and I actually redesigned the BrainCraft HAT in the meantime. So let's go to the overhead, and I can actually, I'll show them what the changes are, and you can chat with the group.
Yep.
So this is the old version, which was actually nearly perfect. It was pretty close. So it has a 240 by 240 inch TFT screen, 5-way joystick, 3 dot star LEDs. There's a mechanical on and off for the audio, so that if you don't want it listening to you, you can mechanically turn it off, and it will actually cut the power to the microphones. Left and right microphones on opposite sides, so you can do stereo beamforming, simple beamforming. Some stemma ports, so you can connect power ground data for servos or buttons or what have you. 2 speaker outputs, headphone output, and then a little stemma connector here. And there's a lot of goodies on the back. You can see here we're using this codec, the WM, I think it's the 8960, which is used in the Seed speaker hat. And what's really nice, it's a low-cost I2S codec that has both audio input and speaker drive. So it's nice because you can do stereo audio output through speaker, headphone output as well, through a separate output, because this is bridge tied load and this is analog, and 2 analog microphone in. So this is a very nice little codec that does all the I2S audio work for the audio recognition projects that we've been doing. And then the thing about the display is that it gives you visual feedback for when you're doing vision projects, because vision and audio are kind of the 2 machine learning topics. So this is the new version, and what's updated, I'm using this cool Pimoroni Black Hat hacker so I can like probe the signals while I'm working on it. So it still has almost everything is identical, but I added a little spot here. You can see these SMT mounts, and this holds a fan. So I don't have it mounted right now because of course this is off the Pi, but the fan bolts onto the back, and so when you put the hat onto the Pi 4, there's a little fan underneath that blows air, and that really helps because we've noticed, you know, when you're starting doing machine learning, it's okay, but once you get into like 15, 20 minutes of machine learning, you definitely start heating up, and you can actually start throttling the Pi 4 if you're doing a lot of computation because it's very computationally heavy. So I can turn it back on if I like.
Okay, I'll go to the computer real quick.
Let's go to the computer.
See what folks are doing here.
So yeah, so one of the fun things is that I got to name the service Adafruit fan service. And now if you go to the overhead real fast, you'll just see it's running. I just wanted to show people. So that's the fan. So that's kind of cool. It's controlled by a GPIO. And then I thought I'll just run the TensorFlow demo maybe. Do you want to do that? Start with that? Okay, cool.
Demo.
I'm going to have to copy and paste the commands because I cannot remember all of them. So it does take a little bit to start up. It has to load a bunch of stuff into memory. I have it come up with this BrainCraft logo that Phil and Bruce came up with. It's very nice. And then what happens is that this is actually showing what's on this camera. So like I'm waving at this camera that I've got right here. And what's cool is the output. And you can see like there's Phil behind the scenes doing all the work.
Wow.
You can he's a lot. What are they saying? So what's neat is that while it's looking for stuff, if it recognizes something with over 50% confidence, it'll speak through this little speaker that's connected to the audio hat, which I thought was really cool. We want to have visual and audio output. So let's point to like my keyboard.
Computer keyboard.
Yeah, it's pretty good. And then I think...
By the way, like, there's a lot of AI and machine learning stuff going on. This is like, this is the only thing that like works out of the box that has a good demo.
Oscilloscope.
I love how it says oscilloscope.
Yeah, and it works with a low-cost platform like Raspberry Pi. So we're getting requested from giant companies to do machine learning and AI stuff. And these are like multi-billion-dollar companies, and they're like, Adafruit, can you do all the work? And we are going to do a bunch of work, but we want to do it with something that's easy that everyone can participate in. So this is one of the first examples, and we wanted to also call it something that people would know, because like AI, machine learning, what does that mean? Nothing. BrainCraft, you're crafting little brains.
I love the name.
Yeah.
So next up, can you just quickly go to the computer real fast? We're gonna bounce back and forth.
Yeah, sure.
So over here you can see I have another window, and I'm running VCGen, which tells me the temperature. So you can see as it starts to do this computation, the temperature is rising. It's up to 61 degrees, and that's why I wanted to revise this to add the fan. So if I'm gonna just kind of manually put the fan on top of the chip. I think I got it on top. Yeah. And then when I measure the temperature, it'll slowly come down. Obviously, you know, when you have the hat on top, it's going to have the fan all the time, and it'll keep it nice and cool. So you can see it was starting to get to 61. Now it's heading towards 57, 56. It'll get down to like 40 something. So that's the video demo, and that one's really computationally heavy. And so I thought the next one I would do was the Google demo. You want to do that one next?
Yeah. Do you want to go to the overhead, or do you want to do it on the screen here?
Let's do it on the screen actually, because there's you know I like how it prints out what it recognized. Okay, so this demo uses Google. Like basically, you register with Google and get a key. And then you just install their software. It's actually pretty easy, and give it like, you know, this authorization, and then you can basically make a Google Assistant with a Raspberry Pi and this hat, and it uses the speaker driver to speak back to you and the 2 microphones. And actually, like, it's quite good. Like the microphones pick up commands really well. So in this demo, I just have to hit return and then ask it a question. Okay, Google, what time is it?
It's 10:07 p.m.
That's pretty good. You want to do one?
No, you're closer, so you may as well do it.
Okay, Google, what's the capital of New York?
Albany is the capital of New York State.
Do you do the coronavirus statistics
It's long.
as terrible as this is, but it's very updated real-time information. Let's see if we can get it.
Okay. Okay, Google, how many people have tested positive for coronavirus?
Sorry, I don't have that information about coronavirus.
What did we ask before? It was... Okay, Google, how many people have coronavirus?
According to Wikipedia, as of August 9th, 19,769,560 total confirmed cases of coronavirus disease have been reported worldwide. Keep in mind that the data changes rapidly, so it may be inaccurate or out of date at times. Information about reported cases is also available on the World Health Organization website.
Okay.
And what's on the screen when we're doing this? Anything?
Right now, nothing, because I haven't updated the script to output the text
Got
to.
it.
I want to update the script. So you see, like, the text as it like comes in. I want that to be displayed so you can see what it's saying.
This is powerful. You can do all of this on a Raspberry Pi and a BrainCraft HAT, which will be out soon.
Yes.
And this is a good example of machine learning. So you were working on the hardware over the weekend, and you had to find something.
That's right. So I'm going to segue into our next part of this show, which is the great search.
Yeah.
So
we want to thank DigiKey.
Thank you, DigiKey,
for helping us out with our store, with all the things we're doing. And LadyAda is an expert in searching DigiKey, so he said, "Hey, why don't we show, as part of our partnership with DigiKey, why don't we show how LadyAda uses the search?" And so you just did this, so let's go and check it out.
All right, so back on my computer. So this is the hardware design that I'm working on right now. And like I mentioned, I needed to get a low-cost codec that had stereo audio input, stereo output with speaker drive, and also headphone output. And there's not a lot of chips that do that. One chip that has Raspberry Pi Linux kernel support, like you can compile a driver for it, is the I always get this wrong, WM8960. So you can see over here that this chip has a lot going on. It's got headphone out. This is HP headphone out. It's got speaker out too, stereo, bridge tied load speakers. Wow, amazing. 1 watt a piece, so that's really great. You can have more inputs if you want line level inputs or line level outputs. That's pretty cool and powerful. But there is one thing that's a little annoying about this chip, especially when you're dealing with the Raspberry Pi, which is it requires an M clock pin. So for I2S, you need the bit clock, and that's usually running at a couple megahertz. You need the LR clock, and that tells it when you're sending left data or right data. It's kind of like SPI, it's like the chip select. It tells, if the pin is high, it's the right data coming through. If it's low, left data, or whatever. And then the data in and out, so that's actually the serial data of the PCM data, like what is the waveform going to look like for the input and the output. And then for this chip, it also requires a master clock, and the master clock is going to be some greater multiple of the bit clock, and you can usually tune it, and you need that to make the chip run. It's basically the clock for the chip. It makes it run fast enough that it can read all the data and manipulate it and do any filtering and everything and output it. So, and you want that to be a pretty good clock, because it has to synchronize with the rest of the inputs, and they're going to be very precise at 48 kilohertz, for example, for audio. But even though this chip requires an M clock, the Raspberry Pi does not have an M clock output. Why? I don't know. It doesn't though. And there are a lot of chips that don't need an M clock. But this one does. And so it's could I find another chip, or could I cobble together a solution that doesn't require an M clock input? Yeah, but this chip was inexpensive, and all I need to do is add an oscillator. So today I'm going to show you how to find an oscillator. So go up to DigiKey, and here's the thing: there's resonators, there's crystals, and they're oscillators, and they're all different. So what's nice about an oscillator is it'll actually give you like a square wave output. You don't have to set up a NAND gate, and you don't need any capacitors. It's basically you give it power, and there's an enable pin, power, ground, enable, and output. It's like 4 pins, super easy. So let's look for oscillator. And you can see here that you get crystals and oscillators, but we don't want a crystal. A crystal is when you have a chip that has a crystal in and crystal out. You put the 2 pins of the crystal across it, and it has the driver that will run the crystal. In this case, this chip doesn't have that. It doesn't have a crystal input. It has an M clock input, so we want an oscillator. And there's also like programmable oscillators, which are super cool, but like that's more expensive, and we don't need those. Okay, so we'll load up oscillators, and I love that there's like 670,000 different oscillators because so many chips need a clock drive. I also remember, I think when I did CPLD stuff like in college, I think they also needed an oscillator. They needed an actual like clock input. So first up, I'm going to go with active and normally stocking and real Haas parts, and that gets me down to a mere 500,000. So you can tell, like, you know, they stock a lot of stuff at DigiKey. Okay, next up, the frequency. So in this case, I'm going to be using the same kernel driver that Seed's using, and for theirs, they've already kind of set up all the registers for the chip for 24 megahertz. So you see on this page in the data sheet for the WM60, they say, okay, what's your M clock and what's your, you know, desired like frequency and all that, and they kind of give you these numbers. In this case, the driver's already set up for 24 megahertz exactly. So I will pick from here exactly 24. And you can see there's like every possible frequency you could ever want. But let's just do that. So that at least cuts it down to a mere 4,000. Again, I only want to search the tape and reel because I'm going to be making a lot of these. I'm going to be ordering about 1,000 a time. So I might as well do the pricing with respect to tape and reel. Now I'm going to look at the more filters because I still have a little bit too many. Trying to remember. Okay, so I wanted a 4-lead package, and I do not want a BGA. I do not like BGAs. So I will pick around the BGA part for the package in the case. So that's kind of nice. And for the voltage supply, I'm running at 3.3 volts. So to make sure I don't accidentally pick, you know, it's not usual that you will find the most common, the least expensive part is like 0.9 volts, but you might as well filter them out so you don't accidentally pick something. So don't forget to hit Control, and you can jump over values to make sure you only pick out the ones that are 3.3 volt, and then 5 volt is too high, 1.8 volt is too low. All right, so down to 250. And I think around now, the only other thing was the dimension. So I don't have a ton of space on the back of the board. It's kind of in a cramped spot. I mean, the board's large, but that actual spot isn't very large. So I wanted to pick crystals that were less than 5 millimeters by 3.2 millimeters. And then I don't think I had to do any other searches. I don't care about the height. That's when I started searching by price. And because it's in tape and reel, you're going to get the pricing per reel. Just watch. Again, the cut tape is going to be a little different. Now, in this case, since I did the search and from when I ordered the product, there's been new items added. So you can see this new marking here. But when I ordered these parts like a week ago, this was the crystal that was the least expensive. So I took a look at it. It looks good. It's like a standard base resonator crystal, has enable disable, 24 megahertz, 50 ppm, which is fine. I like that it was low current, had a good temperature range, and it was nice and small, 3.2 by 2.5 millimeter. And this was the crystal that I picked. Now, it's out of stock. It was in stock before, and that's why you want to watch out for when you're searching, and there's that checkbox that you can select in stock or normally stocking. If you need something tomorrow, pick in stock, because it's only going to tell you what's in stock to ship. However, if you're designing a product, you don't want to accidentally miss something because like somebody like me came in and ordered like all the stock, or maybe the factory's just a little bit delayed because of COVID, so they couldn't get the shipment in. In that case, you want to select normally stocking, because that will tell you items that are normally in stock but just happen to be out right now. And so if you're thinking about a long lead time in manufacturing, which I do, I'll go for normally stocking to let me know like, okay, this is maybe not in stock like this week, but in general, this is available, and if it hits the price point I need, then I'll pick it for my product.
Okay. Well, that's another great search.
Yes.
Thank you so much, LadyAda.
Yeah, and on the overhead, I can show the little crystal.
Yeah. One thing about the BrainCraft hat that I'll mention is someone said, "Is that connected to some type of Google device?" No, that's running on the Pi.
Yeah, the Raspberry Pi itself is doing the voice recognition. It sends. I think it does. It does use cloud for the answers, obviously, and I think for some of the voice detection, it has cloud assistance. But it isn't like tied to some assistant.
It's all run on the Pi.
It's basically running on the Pi.
Okay. And what did you want to show?
I showed the crystal real fast.
Okay, great.
So there it is. So all good, and it's as you saw, it was running just fine. So.
All right. So tune in next week. We usually do Jessica LadyAda around 8-ish.
Today we were really busy with
a little
nose
busy.
swabbing.
Yeah, we were swabbing Adafruit
This is
for detecting any dead virus load. There's
Yes.
some new technology out there, so we worked on that. We also got our COVID test. We'll get our results in 7 to 14 days because everyone's getting tests.
Which is good. When we were there, like people came in after, they were all saying they're getting tests.
And one person had an off-topic question, and I answered it, and I put a link up, but I'll mention it here. So someone was wondering about 3D printed masks, and I said, well, it all depends on the mask, how it's being used, who's using it, and all sorts of things. And they said they were using the MERV 13 furnace filters, and I said, watch out for that, because those, and I put a link, those use fiberglass, and you don't want to be breathing in fiberglass. There's a material called Filty that's really good. It's a USA company. We've bought it, and we're trying to experiment with masks. We have some guides on our Learn system, learn.adafruit.com. But there's a lot of information out there now on which masks work and which ones work the best. And if you're going to go the homemade solution, which is totally fine, just make sure you're not making a situation worse by breathing in something with a filter that's not made for humans to breathe in.
Not a good idea.
Even if something can filter the virus, you want to make sure it's not using something that only like a house furnace should be using. So like I said, luckily there's a lot of information out there, and there's a lot of like what DIY masks. The 3-ply cotton ones work really well. The 3-ply blue surgical ones work well. The N95, KN95s, we sell those in our store, KN95 ones. And then the ones that it looks like don't do that well are the basic like t-shirt sleeves around your head. Those ones don't seem to do as much.
You need multiple layers.
Something better than nothing is always good. But if you can, and they're very plentiful now, the 3-ply cloth.
Yeah, you can get those anywhere. I mean, we walked down the street. There were like street vendors selling them.
Yeah, but just about anywhere you'll be able to get them. So, anyways.
Okay, Google, say goodnight.
Yeah.
Have a good night.
Oh, look at that. Thanks so much.
Thanks, everybody.
Oh, one last thing. What happened to the mass crowdfund? So, good news. We have our nonprofit that's being set up. Doesn't look like it makes sense for us to try to fundraise, but we'll be when we have donated masks. So we're going to continue to just move forward with having masks for underprivileged populations. And since we got approved for a nonprofit, we'll be able to raise money for it, but we're not going to have to raise money to get a mass machine that isn't going to happen anyways because there's full supply chain in China. Anyways, long story. We'll dedicate an entire show to it. And that's the idea.
Bye, everybody. See you next week. And, of course, Wednesday on the shows. And all throughout the week, we got tons of live shows.
Bye-bye.